Alright, you guys, this is the second video for this section. Let's continue. So, in the previous one, I showed you a few basic rules for the antiderivative, or how to find it. So once you get those settled in your heads, you'll be able to think up how to find the antiderivative a lot quicker. So I have a few more. These are regarding trig. They're actually all about trig, I think. Yeah. So let me write the same title on top. Basic integration rules. Alright. So let me see. Again, I'm gonna give you guys two columns. One where we have the derivative, the other one where we have the antiderivative, and to see how the comparison between the two looks like. So on the left side, let's do dx of the function sine x, which equals cosine x, right? So derivative of sine is cosine. We already knew that. Now let's do the derivative, or the antiderivative of the derivative of this one. So cosine. I'm finding the integral of cosine x. Remember to always add dx to it. Now the result of this one would be sine x plus c, always, right? So that was kind of straightforward. Let's do the next one. So this one is of cosine x. So this one would be sine x, but remember the sine. So it's negative sine x is the derivative of cosine x. Now if I want to find the integration of negative sine x dx, it would be cosine x plus c, right? Now had I not wrote this negative right here, so if I give you this instead, sine x dx would equal negative cosine x plus c. So how that happened? Yeah? Okay. So now let me do something else. How about tangent? So ddx, integration of tan x would be secant squared x, right? Now integral secant squared x dx, and that equals tan x plus c. Always add the c. Let me go up a little bit. Okay, so let's do dx of secant this time of x, and this one's going to equal secant x tan x. So it's a multiplication between secant x and tan x, and the c and x are kind of on top of each other here, so I'm trying to make it a little clearer. Alright, so integral of the result of this derivative, x tan x dx equals secant x plus c. Yeah? Now, how about ddx of cotan of x? So this one is going to be negative cosecant squared x. Now if I find the integral of cosecant squared of x, notice I didn't write the sign. Therefore, when you integrate dx, that gives you negative cotan of x plus c. So the relation between the signs, or the contrast, if one's going to be positive and the other is negative, is going to be maintained no matter where you start. So don't worry about it too much. But if I did give you a function that is negative, then you should integrate it as negative. But anyway. Okay. So how about the contrast between these two? So derivative of cosecant x is going to be negative cosecant x cotan x, right? And the integral of cosecant x cotan x is going to be what? Negative dx, forgot the dx, is going to equal negative cosecant x plus c, right? So I'm going to go down a little bit, hoping that maybe you could get them the same screen. There we go. So make sure you copy these. These are the rules for the trig functions as far as integration goes. And there's really no way around it. I mean, you can understand how it came about and try to deduce it later on, but essentially you are memorizing these. So it would make your life a lot easier if you did it early on to get it out of the way. When you get to Calc 2, you will see how these integrals and derivatives came about, like why the derivative of sine is going to be cosine and why the integration gives you these results. But until then, that's not really in Cal 1. So anyway, now that we have all these rules down, let's actually get to the part where we solve a few problems. Yeah, here we go. So let's do this one. Integral 3x dx. Okay, and it equals 3. So I'm taking the 3 out, kind of like the rule I showed you, and that leaves us with x dx. Okay, now when I said you had x to the n power, what did we do? So the 3 remains out. We had x to the n plus 1, so making it 2, and then it was divided by the new power, which is n plus 1, so over 2. Makes sense? So that's what I did here. This power became 2, and then I divided by the same number. So you end up with 3 over 2 times x squared. And don't forget the plus c. Yeah? So let me give you one more. How about this one? You have 3x squared minus 1 dx. Alright? So how about this one? Okay. So again, this is basically like one of the rules I showed you, where you have f of x plus or minus g of x. In this case, g of x is just 1. Now, you can integrate right away. You don't have to separate it. But just to use the rule and show you guys what it looks like, I'm going to do that. So we have integral of 3x squared dx minus integral of 1 dx. Yeah? So, over here, 3 can be taken out. So this is me trying to use as many of the basic rules I showed you, hoping that that would give you a little practice, right? So the 3 remains out. It's only multiplied to the first one though. Notice that. Okay. So I'm multiplying it times x to what power? It's going to be n plus 1, right? So 2 plus 1 making it 3, and then dividing by 3. So this cancels. You end up with x cubed, just x cubed. Which makes sense. This is the one we played with a lot at the beginning of the first video. 3x squared. And the answer for that was x cubed. So we found the first one, minus, now over here, derivative of 1, which is as well one of the properties we saw. We had k in the example, but over here you have 1. So when you when you integrate a number, you end up with that number, which is 1 times x to the first power, which is why I'm not writing it down. So after you're done with everything, you add plus c. So there we go. It's x cubed minus x plus c. That's your final answer. Alright, So I hope this made things a little clearer for you. I hadn't realized I was approaching the end here, so this video ended up being a lot shorter than the others. The only reason I keep it going, even though it's easier to just pause or stop it, is because the recording program I use with the DocCam doesn't pause the video. So if I click stop, it has to stop and save it, and I have to start over. So I'm going to keep it running a little bit just to find a few examples for you, hoping that we can get some practice on this. Obviously you have your homework and you can do that, but I wanted to work out a few problems with you instead of relying solely on the homework. So if you want to just close the video and not watch those, you absolutely can. But if you feel like you want to look at a few practice problems with me, keep watching. Alright, let me see. Antiderivatives and okay, here we go. Alright, so I'm gonna do a few examples, try to make it diverse. try to make them as make them vary as much as I can. I'm not sure, can you use the word diverse when it comes to problems? I'm not sure. Anyway, so oops, I actually can't see the camera. Let me do this so I can see what I'm writing. Okay, so here's one example for you. Here we go. Question says, let me close this and zoom in. I can't read that. Okay. So, question says, integral of 6x to the 5th minus 18 x to the 2nd power plus 7 dx. So this is my integral. For some reason my hand already made it go downwards a little bit, but anyway, so now let's solve it. Again, like the problem above, you can technically split this into 1, 2, 3 integrals, and with the first two you take the number out, but that just seems like a lot of work, doesn't it? So instead, let's just solve normally, without. Okay, so the way you solve an integral, even though you have more than one term, is exactly the same way as you would have derived a polynomial with more than one term. You just grab them one at a time and you integrate, yeah? Which is basically distributing the integration to all three. So same thing, but without writing it down. Now, over here, for the first one, you have 6 times x to the 5th power. So the 6 is going to be multiplied times it. Now, x to the 5th, we said x to the n, you add 1. So x to the n plus 1, which is 6. And then you divide by the new power. So 6 over 6, that cancels. Which makes sense. If you ever see a function where you have the coefficient being 1 degree higher than the power of the x, you know that the derivative of this initially was that same number to the power with no coefficient, or the coefficient of 1. Make sense? So that's what happened there. So anyway, so the first one is x to the 6th power. Now minus the second one. Over here, you write down the 18. Bring down the x. It was 2 to 2. 2 plus 1 makes it 3, and we divide by that 3. So the 3 on the bottom cancels, 18 on the top cancels, and you end up with 6, right? So this is 6x cubed. Plus, now for the 7, again, when it's a number and you take the integral of it, you end up with that number times x to the 1st power. And once you're done with everything, you write the c. Now, just to clean things up, because it looks a little messy, I'm going to rewrite, but I'm not changing the values. The answer is already found. So it is x to the 6th power minus 6x cubed plus 7x plus c. Yeah? Alright, now let me try and give you another one. Let's see. How about oh, this one. That looks kind of bad. I like it when the problem looks long. It makes you guys think more. But since you're not in front of me, I can't exactly ask you to do it on your own. Well, actually I can. You can just pause the video. I won't know if you did it or not, but you can. So, here we go. 40 x cubed plus 12 x to the second minus 9 times x to the first plus 14 dx. Right? So this is your function. If you want to try and do it on your own, pause the video now, attempt it, and then play it and see if my answer matches yours. Alright? Ready? One last chance to pause if you want. Okay, here we go. So let's start one at a time. Over here we have 40 times x to the third. So it's going to be what? 40 is the same, x to the fourth, since we're adding 1, and then we're dividing by 4. So 40 over 4, this cancels out, and you end up with 10. So it's 10 x to the fourth, right? Plus, now 12 x to the third, since we're adding 1, and you divide by 3. 12 over 3, that's a 4. So it's 4x cubed minus 9 x to the second over 2. No simplification here, we'll leave it like that. And as far as the number is concerned, you just add an x in there. So it's 14 times x plus c. So that's your answer. I'm gonna just rewrite it to make it a little clean, easier to copy. So it is 10 times x to the fourth plus 4x cubed minus 9 over 2x squared plus 14x to the first power, ignore that scribble, plus c. That's your final answer. I hope you guys got it right. Okay. Let me see if I can find one with trig. That would be fun. To make sure I expose you guys to as many examples as I can. Okay, and the problem set I don't have any trig problems, but maybe we can make one. So I'm literally coming up with this problem off the top of my head, so if it ends up being nasty, I'm sorry about that, but let's see. Here you go. Alright, so let's say you have sine x plus cosecant squared x dx. Yeah? So this equals, again, we have addition, so you just do them one at a time. So the integration of sine x is going to lead you to cosine x, because derivative of cosine is sine, and since this one's positive, that means this one's going to be negative. And then the integral of cosecant squared of x, that's going to take you back to cotan, but because this one's positive, this is going to be negative. So cotan x, and then finally you add the plus c. So both of them are negative because I gave you two values that are positive over here when they have contrast. Okay, so here's another one. Integral. So that was the first. This one secant x squared plus 10x dx. Alright. So the integral of the first is just 10 of x, because secant x squared is the derivative of 10 of x. And then I gave you 10 of x itself, so how are you going to integrate a function you don't know the derivative of? So basically the question is, what is the function or the trig function that gives you 10x as a result of its derivative? What's the antiderivative of 10x? Maybe I shouldn't have given you this one. So ignore that part. I'll just give you plus c. The only reason I'm not going to do it is because to do this is going to be basically 1 over a hyperbolic function, and we introduced that in chapter 5, if not Calc 2. So yeah, too early for that one. Okay, let's do one more. How about integral of cosine x plus, let me see, what should I give you? Secant x tan x. How about that one? Dx. So the first one is the derivative of sine, so I write sine x. The second one is the derivative of secant x, and then plus c. So the trick ones are kind of straightforward. If I want to give you some kind of twist and give them different powers, then we're basically going to go into trig integrals, and those are actually in Calc 2. So I don't want to give you guys that headache early on, since it's technically not part of the lesson you guys are supposed to learn. So I hope this was clear. If you have any questions, let me know. And yeah, this is 4.1.